In this video, we will talk about machine learning and show how to train a binary classification of MNIST images using scikitlearn in Python. So what is machine learning? Actually, machine learning is a compute program to learn from the experience E with respect to some task T and some performance measure P. So if its performance on task T as measured by P improves with experience E. So this definition comes from the book by Tom Mitchell in 1997. So we call machine learning is for training data from millions of, for example, images. So the model can learn the series or tasks by training this model. Then next can predict well on new data it has never seen before. So machine learning is fundamentals for example, artificial intelligence, AI, and there are different types of machine learning program in terms of different criteria, but basically we can divide machine learning problems as supervised and unsupervised. So the supervised machine learning has a target value. For example, if you want to use classification or regression, the classification's target is binary or multiple category variables, but regression's target variable is continuous variable. So we know these target results in supervised machine learning. Then the model will compare the trained model's result with the targeted or known results. So the loss between these two will be less and less when model is being trained. So in the end, get a best model after training, then it can be used to predict the new data it has never seen before. But for the unsupervised model, like clustering, it has no target value. So we have no target data to be compared with the model. So in this case, for example, in clustering, the model will find the best cluster numbers with respect to some measure, and this measure does not come from any targeted value. This from the training data and the model criteria. So in Python, scikitlearn is a Python machine learning library framework. It provides the many tasks like data preprocessing, training data preprocessing, and many different types of modules like classification, regression, and clustering. And it also provides different algorithms like support vector machine, random forests, gradient boosting, k-means, and dbScan algorithms. And scikitlearn operates well with other Python libraries like NumPy and SciPy. It also, in some cases, operates with other machine learning framework in Python like TensorFlow. So sometimes in TensorFlow machine learning, called deep learning, it uses scikitlearn's data preprocessing tasks procedure. So in this video, we focus on a very simple binary classification task using scikitlearn. It is based on an MNIST dataset, and this dataset contains 70,000 handwritten digits image data. So classification of MNIST data is usually called the hello world in machine learning step. So from this step on, can go further and further to learn more advanced machine learning program. And in this classification task, we will use the algorithms called statistic gradient descent. The gradient descent is an optimization, mathematical optimization procedure to get the best module parameters based on the loss function between the training results and the target results. And the statistic here means in each step iteration of the update of parameters, there's only one data used, one random data used. So here is one image data used. And we also will use k-folds cross-validation for the training data to get the accuracy, or we say the measure of the accuracy in the training process to measure the performance. So now we will start to learn some code in Python for this task. First, we set the working directory using module OS. Then we import module sys to check the version of the Python is over 3.5. Then import scikitlearn module for the scikitlearn. So you have to install this module I use Anaconda. So you, for example, if you use Anaconda, you go to activate the environment you have created under Anaconda. Then if you have not installed scikitlearn, you have to install scikitlearn using conda. For example, this module equals the version is 0.20, right? So we import this module. Then next import NumPy module. In the machine learning, the most widely module from the Python includes the NumPy module. And we set random seed for 42 so the results can be reproduced with the same results. So next, several lines of code set import matplotlib library and set some options for the label size for axis Y and XY label. So this part of the code will create a project directory and with the chapter ID called classification and the working directory. Then this part of the code will set and create a function called savefig. So there are lots of figures will be created during the program. So we will set a function called savefig. Next, we can use this function. So it quite be easy. So now we will get in touch with the dataset. So from scikitlearn's datasets, import module called fetch OpenML. Then that means the data set can be loaded using fetch OpenML with this MNIST 784. This is the image size that was the version 1. Sorry. Take several seconds. Okay. So the data is stored in dictionaries, Python dictionaries. So we first show the keys of this dictionary. So the keys include the data, target, feature names, and others. So we use the data and target. So let's just check out the value of this dictionary. So MNIST data and MNIST target set to X and Y. So X is a NumPy array, so we use the shape attribute to show X. The shape is 70,784. For example, X 10. Oh, sorry. Oops. The Y shape, the one dimension. We just show X. So the X, the first row of X is 784 elements in a list, right? There are total 70,000 rows, and Y for the digits label. First one is 5, the next is 0, and so on. So we import matplotlib again. Then we take out, for example, the first element of X, the first image. And we reshape to the 28 by 28. So now I can see that this particular image data is 28 by 28 NumPy array. And each element's value between 0 and 255. 0 represents white and 255 represents black. The other value is between white and black. So because this data image for the version 1 is for black and white data. So next we use plot imshow to show the matrix of this two-dimension array for this picture. And imshow is particularly used for show the matrix of this data. So this fig looks like 5 handwritten digits for the 5. So this for the 28 rows, 28 columns. So we show the target value for the Y. For the first Y, it's 5. Label is 5, right? Because the machine learning have to use numeric data, so we set the Y's as type to integer value, NumPy's integer value. This function not used, but we just run this function. So next function is called plot digits. To plot 100 values arranged in row by row, this function is used. So next we can plot the first 100 training data using this function, plot digits function we created earlier. So this is the first 100 training data for the MNIST dataset. Handwritten digits. So each one is actually arranged with a 28 by 28 NumPy array, and each element for this 784 elements is between 0 and 25. For example, this one is 0, is white. This place is black, is 255, right? So next we will set the training data and test data. So test data is for the prediction. So we assume this test data we have never seen before for X test and Y tests. The model is based on the training data. To train, X train, and with a target value Y train. So here we manually set X train data and training data and test data. So the first 60,000 data of this MNIST dataset is used for the training, and the last 10,000 is for the test. So X test is from 60,000 to the last one, and similarly for the Y. Because in this module, in this video, we will train a binary classification model. So we just focus on the Y value is 5 or not 5. So we create the new training and test for the Y. For the target value, we will underscore 5 in the name. So their value is Y train equals 5. Actually, is Boolean result, right? And Y test equals 5 or not. So it's Boolean result for the Y value. So for example, we can show now the Y train target value for the training module. Target value is true, false, false, true, false, false, right? So this is only for the target value is 5 or not. So this one is 1, this is 0. 1 means this image is 5. False means this image is not 5. Similarly for the test value also. Then we can train the module. So first we have to import training algorithm called SGD classifier from scikitlearn.linear module. Then we can create a module called SGDCLF from this SGD classifier class. Then we set the max iteration 1000 and the tolerance 1e-3, then random state 42. So only one line can create this module class. Then we can use this model to use the fit function. So in scikitlearn, most of the module use fit, means to train the module. So this line is used to mean to train the module. And the training data, the X train, Y training Why target data is Y train 5? Because we use binary classification. So this is the data we have created in the previous lines. The 5 or not. So 1 0 1 0 1 means 5 0 not 5, right? So next we train this module based on this data. Take some time. Okay, finished. So we can use the trained module trained to predict function. This is the trained module to predict with some input x value. So x value here we use some digit. Actually is the image of digit 5 we have shown before. This is the x value for this digit. So we predict the result is true. Because this is 5, the result to the module predict this from this X train data is true, is 5. So this means the module predict right for this data, for this image, right? And the module train is not finished yet. So we have to measure the performance of this module. And this is usually use cross-validation. What means cross-validation? So training data, for example, 60,000 images. So we divided this total training data into several parts called folds. For example, here we divide 3 folds. So each has 20,000 images. Then, because there are 3 folds, so we can take each of these 3 folds as a test data in the first run. Then use the other 2 folds, means 40,000 images in the training data. So, which means we use model to train upon these 40,000 data. Then use this trained model to evaluate the accuracy on left on the 20,000 data not being trained. So we can run these 3 times with a different training data and a different test data. Then we can get 3 accuracy scores with different folds, right? So we import this module called cross value score from the module selection from Scikit-learn. Then use this class to run the SGD trained module with the X train and Y train 5. Then we set the folds 3. So this command will automatically divide X train data into 3 folds, then run 3 times with different training data, including 2 folds, and evaluate the prediction on the other 1 fold. So these kinds of learning run 3 times. Take some time. So the result, you can see the accuracy is 0.96, 93, 95 for 3 different folds, right? Another performance is used based on stratified sample. What means stratified? So in the classification module, so the target value, for example, they're about 10% with the 5 label, 5% with the 1 label, and 50%, very high percent with the 10 value or the 9 value. So there are different percent of the different categories, right? So stratified, which means if we do the training, we will sample with the different folds, but with different folds will have the same percentage of different categories. So we will avoid to get the unbalanced data. So this is called stratified data. So stratified data will get better results, better accuracy to model the real data. So in this opinion, so we will import a model called stratified k-folds here. And we also import a model called clone, which will be used later. So with the stratified k-folds, so we can also create an instance from stratified k-folds class. Also with the split 3 for the 3 folds and shuffle true random state. Then we can run a for loop for different folds from the training data, target data, then use a clone of the model we have trained before. Then we can measure, can use this model to train, to get the training data folds and the test data folds to measure the performance, right? So here is predict. So we train again, the model train again based on the training folds. Then predict again based on the test folds. The difference between this one and the earlier is here the data is divided by the different folds based on the stratified mechanism. Stratified for the different class, 5 or not, 5 or not. So we learn this part of the codes, takes some time. So this is the first fold has been trained. So second, can see this result little bit different. From the last one without stratification, right? And in the end of this video, we will show a model called never 5 classify. So what it means? So because we have seen performance of about 0.95, it's good or not, we never know, because this depends on the data. But simultaneously, we can run another module called never 5 classifier. So in this module, we always predict this is not a 5. So actually this is nothing done. But this module is a very basic, or also say 0 module. So we call this base module. So import base module estimator. Then we predict, only use zeros. So we always predict 0. So this model created from this class. Then we use this module to show the performance of X-tree data and Y based on X-tree and Y-tree data with 3 folds. Can see this module has about 0.90 accuracy. So even we do nothing of model training, so we can get about 0.90 accuracy. Why? Because in this dataset, only about 10% of the data class category is 5. So we say 100% is not 5, which means we have get 90% of data is correct in classification. We only have failed for 10% of the data, which actually are 5, but we predict them as not 5. So we have 90% of accuracy, even we do nothing with the model. So from this simple classification task, actually this is quite a complicated issue for the performance. Not easily to say this model is good or not, or say which model is the best model we want to stop. So in summary, in this video, we provide the very first beginning of the machine learning in Python with a binary classification model for the MNIST data, image data, with a black and white image. So in the next videos, we will go step further to show little by little of the performance and model structure and the training algorithms and the data preprocessing steps. So thanks for watching this video and hope you will enjoy and like this channel, because we will make more videos on machine learning with scikit-learn and further with neural networks in TensorFlow. Thanks for watching. Thanks for subscribing.